Hello everyone, this is Vasundhara, PhD scholar of Department of Dairy Science and Food Technology, Banaras Hindu University. I'm here to present the topic X-ray crystallography. So to start with, these are the content of my presentation. Now, the introductory part. So, it is basically a non-destructive technique, and this method, what we do is we determine the arrangement of the atoms within a crystal. So it is said to be a very powerful technique for visualizing the structure of the protein. It is basically the tool for identifying the atomic and the molecular structure within the crystal. What we do in this technique is we measure the angles and the intensities of the diffracted beams. A crystallograph basically produces a three-dimensional picture of the density of electrons within the crystal. From this electron density, the mean position of the atoms in the crystal can be determined, as well as their chemical bonds, their disorders, and various other informations can be obtained. This is the basic diagram. Now comes the principle of X-ray crystallography. The principle of X-ray crystallography is that the crystalline atoms cause beam of X-ray to diffract into many specific directions. It is basically, we can say that it basically uses the principle of X-ray diffraction to analyze the sample, but is done in many different directions so that the 3D structure can be built up. Before knowing the actual X-ray crystallography technique, we need to know what X-ray is. So X-rays are the beam of electromagnetic radiations. They have a wavelength smaller than the visual light, have higher energy, and are more penetrative. Now, before knowing the different X-ray methods, we need to know what a crystal is. So a crystal is a solid whose atoms are arranged in highly ordered repeating patterns. These patterns are called as crystal systems. Now, why these X-rays are used? These X-rays have wavelengths similar to the size of an atom. So X-rays have smaller wavelength than visible light, so they have high energy and can penetrate the matter more easily than the visible light. So X-rays are used. Now, why crystals are used? When sample is present in liquid form, the bond angle keeps changing. So the position of the atoms keep changing in every moment. So it is very hard to determine the structure of that sample. So when we change biological liquid sample in crystalline form, or we can say solid form, the conformation of the molecule is fixed in a single place. So it makes easy to determine the structure of that crystal. So now coming to the different X-ray methods. There are basically these four methods which are employed. So the first one is X-ray absorption method, Auger X-ray emission method, X-ray fluorescence method, and the fourth one is X-ray diffraction method, which is also known as XRD and is very frequently used in the food industry. The first one is X-ray absorption method. So in this method, what we do is it is basically similar to absorption in other regions of electromagnetic spectrum like UV visual, or we can say IR spectroscopy, etc. The wavelength at which a sudden change in absorption occurs is used to identify an element present in a sample, and the magnitude of the change determines the amount of the particular element present. Now, the second one is Auger X-ray emission. In Auger X-ray emission, the primary X-ray ejects electrons from the inner energy cell, or we can say level. Now, just the outer level electron falls into the vacant energy level by non-radiative process. The excess energy ejects electrons from the outer level. Now the third one is X-ray fluorescence method. In this method, the primary X-ray ejects electrons from the inner energy level where the wavelength is equal to the absorption edge. But when the wavelength is shorter than the absorption edge, it emits secondary X-ray when electrons fall into the inner vacant levels. The fourth one is X-ray diffraction method. X-ray diffraction works by irradiating material with incident X-rays and then measuring the intensities and scattering angles of the X-ray that leave the material. When a beam of monochromatic X-ray is directed at a crystalline material, one absorbs the reflection or diffraction of the X-ray at a various angle with respect to the primary beam. Now, the relationship of the X-ray angle of diffraction and the distance between each set of the atomic planes of crystal lattice is given by Bragg's equation, which is n lambda is equal to 2d sine theta. Now comes the instrumentation part. The first one is the production of X-ray. So the X-rays are produced inside the X-ray tubes when high energy projectile electrons from the filament interact with the atoms of the anode. Now, what is an X-ray tube? So an X-ray tube is a large vacuum tube containing a heated cathode of tungsten filaments and copper and any other metal anode. It is basically operated at a voltage of 60. Before knowing the second part, there are some more things we need to know about the production of the X-ray. So, there's a cathode, which is a filament of tungsten metal heated by a battery to emit the thermionic electrons. This beam of electrons, what it does is it moves towards the anode target and attains the kinetic energy, and then 99% of the energy is converted into heat via collision, and remaining 0.5 to 1% is converted into X-rays. Generally, the target gets very hot in use, so this problem has been solved to some extent by cooling the tube with water. So, we need to know what actually happens. So, if significantly energetic electrons are available, the transfer of energy from the electron beam may eject an electron from one of the inner levels or cell of the we can say the cell of the target atoms. Within each atom, the place of the ejected electron is promptly filled by an electron from an outer cell, whose place in turn is taken by an electron coming from still further out. Thus, the ionized atom returned to its original state in a series of the steps, in each of which an X-ray photons of definite energy is emitted or excess energy is related or released by ejection of a second electron with characteristics energy. What happens is the K cells of the line is observed when an electron in the innermost K cell or level is dislodged and electrons drop from the L level or M level into the vacancy in K level. Correspondingly, the vacancies in the L level are filled by electron transition from outer levels and give rise to L series. Now, coming to this second part, collimator. So, it is used to get the narrow beams of X-rays. To get a narrow beam of X-rays, the X-rays generated by the target materials are allowed to pass through a collimator, which consists of two sets of closely packed metal plates separated by a small gap. The collimator absorbs all the X-rays except the narrow beam that passes between the gap. Now the third one is monochromator. So there are basically two types of monochromator which are used. The one being filter and the second is crystal. Now, what is filter chromator, monochromator? A filler or a filter is a window of material that absorbs undesirable radiation but allows the radiation of required wavelength to pass. And the second one, crystal monochromator, is a made up of suitable crystalline materials positioned in the X-ray beam so that the angle of reflecting planes satisfy Bragg's equation for the required wavelength. Now comes the detector. There are various type of detectors used in various types of machines. In the methods which are used in this crystallography technique is photographic method. The first one is photographic method. In order to record the position and the intensity of the X-ray beam, a plain or cylindrical film is used. The film, after exposing to X-ray, is developed. The blackening of the developed film is expressed in terms of density unit D, given by D is equal to log I naught by I. The second one is counter methods. The Geiger tube is filled with an inert gas like argon, and the central wire anode is mentioned or maintained at a positive potential of 800 to 250 volt. 2500 volt. When an X-ray is entering the Geiger tube, this ray undergoes collision with the filling gas, resulting in the production of an ion pair. The electron produced moves towards the central anode, while the positive ions move towards the outer anode. The electrons is accelerated by the potential gradient and causes the ionization of the large number of argon atoms, resulting production of an avalanche of electrons that are traveling towards the central anode. The Geiger tube is inexpensive and is relatively trouble-free detector. We can say that this tube gives the highest signal for given X-ray intensity. Now comes the application of the crystallography. Now, this technique has various application in various industries. So, the first one is it is very useful for characterization of crystalline materials. It is also used for identification of fine-grained minerals such as clays and mixed layers clays that are difficult to determine optically. So, it also determines the unit cell dimension measurement of sample purity. It determines the cis-trans isomerism. It differentiates sugar. It is used for X-ray analysis of milk powder, and it is also used for the determination of structure of protein and DNA. These are the references which have been used. Thank you.